It is important to note that correlation does not indicate causation. In other words, just because two variables appear to have a relationship in their variability, it does not necessarily mean that the specific increase or decrease of one causes the increase or decrease of another. In the last video, we talked about two variables. We talked about income and savings. And we called income the independent variable, and we called savings the dependent variable. And we felt pretty strongly that elevated income could have an effect on savings. And it seems to make sense that the more money someone makes, the more their potential for savings. So it seems that income should have an influencing effect on savings. So that's why we had income marked as X and savings marked as Y. Now, often these two variables, rather than being termed independent and dependent, are termed explanatory and predicted. Sometimes, rather than predicted, you might see the term response variable. How does the dependent variable respond to changes in the independent variable? But as we just stated, sometimes there may not be an actual causation. And as a matter of fact, causation is very difficult to prove. And as we said, it does not necessarily mean that the specific increase or decrease of one causes the increase or decrease of another. So let's look at another example. Let's look at the two variables, sales of farm machinery and loss of timber acreage due to wildfires. And let's suppose that we were to put sales of farm machinery, so amount of money, on the x-axis, and acreage, so the variable loss of timber acreage due to wildfires, on the y-axis. And let's suppose that, we had a scatter plot that looked something like this. Might have had an outlier or two somewhere like this, but appeared to have quite a negative and linear looking relationship. And it would appear as though we could draw some sort of a straight line through this data like this. But in our minds, it seems, well, how would sales of farm machinery have an effect on loss of timber acreage due to wildfires? And in reality, it certainly doesn't. So we would say that these two variables do not have a causation effect. But something that we might do is look at other influencing variables. So let's consider what happens during drought years. During drought years, farm production decreases, which results in fewer farming dollars available for the purchase of machinery. Another effect of drought is that timberland dries up and brings a greater potential for wildfire. So this introduces the concept of the lurking variable. So if we consider rainfall, then, when we have less rainfall, then we have fewer dollars available for the purchase of farm machinery due to loss of farm production. So that would put us down here towards the bottom end of this axis. At the same time, we have much drier timberland, which increases the potential for wildfire and the loss of timber acreage, which would put us higher then on this axis. So we have this variable that may be causing this effect here, whereas the amount of dollars available for the purchase of farm machinery increases, the amount of acreage lost due to wildfire decreases. A lurking variable, then, is one that influences the relationship between other variables, but is not specifically mentioned in the analysis. Lurking variables can falsely indicate a relationship between two other variables.